This video will provide an overview of the Radioline wireless system, which can be useful in applications where constant monitoring and control of I/O and serial devices is needed. Some examples of applications and industries where these problems arise are the monitoring of remote tank levels, pump stations, and wells in the water-wastewater sector, the control of variable message signs on highways or the lighting of waterways, efficiency and power usage of local power stations, photovoltaic systems, and wind parks can be monitored and trended. The oil and gas industry also has large-scale systems where there are many sensors, actuators, and PLCs in hazardous locations that need to be constantly monitored. The main feature of the Radioline wireless system is the simple I/O mapping. With just the turn of a wheel, analog and digital inputs and outputs can be easily transferred by radio or cable without programming. The I/O mapping works in point-to-point, multi-point-to-point applications as simple cable replacer. The self-healing network function of the trusted wireless technology provides high reliability over long distances or in tough RF environments. In addition to simple I/O communication, serial field bus protocols such as Modbus or Profibus can be transmitted wirelessly. Furthermore, hundreds of sensor signals can be captured wirelessly, transmitted to a central control center, and integrated directly into control systems via Modbus RTU protocol. Wired Radioline stations can be operated together with wireless modules in the same network. All I/O devices are hot swappable, have galvanic channel-to-channel isolation, an extended temperature range of -40 to 70 degrees Celsius, and approvals such as UL, IECEx, and ATEX. This makes the Radioline system flexible for use in the process industry. The Radioline system consists of different head modules for different countries and applications. The wireless modules use only license-free frequency bands, which do not require local licensing or reaccruing data plans. For worldwide use, wireless modules are available using the 2.4 GHz band. These devices can be used to set up networks with up to 250 stations and bridge ranges of 5 kilometers or 3 miles with line of sight. For use in Europe, an 868 MHz wireless module is available. This wireless module can be used in applications with longer range requirements. Distances of up to 20 kilometers or 12 miles with line of sight are possible with the correct site planning. Depending on the number and type of obstacles, ranges of 3 kilometers or 2 miles and more can be achieved without line of sight. For use in North and South America, as well as in Australia, a 900 MHz wireless module is available. With the 900 MHz frequency band, ranges of up to 32 kilometers or 20 miles are possible with correct site planning and line of sight. The delay time of the radio modules is between 50 milliseconds and several seconds, depending on the frequency band, network size, and range. With the wired RS-485 Radioline head station, up to 99 remote stations can be networked over any two-wire cables with a length of 1.2 kilometers. Larger distances can be obtained with the addition of SHD-SL extenders, fiber converters, or cellular modems. Several analog, digital, and PT100 extension modules with 4 or 8 channels are available. Up to 32 I/O modules can be connected to a head module via a DIN rail bus connector. Only input and output modules of the same type and channel combination can be paired with each other. For example, a 4-channel digital input module can be mapped to a 4-channel digital output module. Signal duplication is possible where a single input module can send the same signal to multiple output modules at different locations. 4 operating modes are available using the free SciConf configuration software. In the factory default settings, the I/O to I/O mode is activated. With simple I/O mapping, analog and digital values can be transmitted between any stations in the network without using software. In serial data mode, RS-232 and RS-485 interfaces can be transmitted wirelessly, replacing faulty bus cables or connecting remote assets where a serial cable cannot be connected. The wireless modules are completely transparent to the network. In the PLC Modbus RTU mode, I/O signals of the remote stations are output at the master Radioline module via Modbus RTU protocol. This reduces the potential number of I/O modules in the cabinet, reducing cost and space requirements. In this mode, the 8-channel digital input modules can be operated in pulse counter mode. As a result, pulses up to 100 Hz can be transmitted. In the PLC Modbus RTU dual mode, the Modbus RTU protocol can also be transmitted in addition to I/O signals from remote stations in parallel. This allows further Modbus RTU devices, such as measuring devices, inverters, or control systems, to be connected at the remote Radioline stations. With the free SciConf software, the different operating modes can be selected and advanced device settings can be made. In addition, a comprehensive diagnostic of all stations in the network can be viewed. For I/O to I/O configurations without software, a conf stick can be used to uniquely configure RF parameters to operate several radio networks in parallel. This setting can also be set in the SciConf software. With the use of simulation software, we can create a feasibility study and evaluate the feasibility of a wireless network with a high degree of accuracy before an on-site test. To request one of these studies, GPS coordinates will be needed for each planned site. For more information regarding Radioline, please contact Technical Service at 1-800-322-3225.